Hello. Welcome to Managing Technical Debt Before It Blows Up in Your Face. My name is Amanda Sopkin. I am an engineering manager at Asana, and I'm really excited to talk about this topic today. I've been thinking about it a lot in the last couple of years. Throughout my career, both as a software engineer and as an engineering manager, I've been involved in different technical debt projects, and I'll level with you and say that they've had kind of variable levels of success. And at the end of the day, I really believe that technical debt is inevitable because we are human beings, and we make the best decisions that we can with the information that we have in a given moment. But those decisions are not guaranteed to scale well with a particular company. So really because we're human beings, or as Gemma said, funny little animals, and also because we cannot predict the future, we end up with technical debt. And hopefully you'll get some tools for dealing with that technical debt out of this talk. So I'm going to use this term technical debt, and I want to acknowledge that I think it's a little bit overloaded. So I'm going to use it to refer to several different concepts that kind of fall under this umbrella. Could be refactoring work. It can also be some kind of investment into your infrastructure, like potentially you want to improve your release process, and that can be a form of technical debt. It can be some kind of hacky solution, maybe that came out of a hackathon or some kind of a bridge timeline, and you now need to go back and make it robust. It can be some kind of new innovation that you want to adopt, like potentially a new open source tool, a new framework that's out there, anything that you want to build or buy. And it can also just be some kind of old pattern in your code base that maybe hasn't scaled well with the company. Maybe it made sense a few years ago, and it just doesn't make sense with where you are today. So all of those things kind of fall under that umbrella of technical debt. And we have a short time together today, so I'm going to focus on specifically giving you tools to answer this question: when should I pay my technical debt? Prioritizing tends to be one of the hardest aspects of technical debt in organizations in general. So the first thing I want you to think about is impact, both the impact to the developers in your company and the impact on your customers. And those are very interrelated concepts, as we'll talk about. So you are probably familiar with some measures of impact, like, for example, page load performance or downtime. But I'm going to talk about a couple of the less obvious ones. So a big one that impacts your developing team that I personally feel is underloved is build times. So you might be making some kind of technical investment to help adjust your build times. And let's say that you're trying to take your build times from an average of 40 minutes to 30 minutes. That doesn't sound super impressive on paper, but if you can imagine for a moment that you work at an organization that has 100 developers, and let's say, just to keep this simple, that they're each doing an average of 1 build per day. So you have 100 builds happening every day, and you're trying to save 10 minutes on every single build. If you end up doing that, you're going to save 1,000 minutes in developer time, which is around 16 hours. And if you work a 5-day work week, that's going to come out to around 80 hours in a single week. And if your developers are well paid, which they probably are and they should be, that's worthwhile time. So I believe that this is worth investing in early, not when super late down the line when it's very difficult to release anything at all. Another example of something that impacts your customers could be related bugs. So when it comes to bugs, sometimes things are straightforward. Someone reports a bug, you fix it, end of story. But sometimes you end up with these kind of like spooky or rotten areas of your code base that just seem to be really buggy for some reason. As an example, I worked on a team that had a really complicated data model. And we were constantly getting customer requests that required us to go in and manually alter customer state. And we kept patching fixes, but nothing seemed to really help until we actually went in and refactored the data model to make it significantly simpler and easy to reason about. And that took us from around like 10 bugs a month to on the order of 1 bug every 2 or 3 months. So sometimes it's worth taking a step back to try and see the forest instead of the trees and make a more serious investment that'll end up clearing a lot of bugs at once. And then a third measure of impact, this one is particularly difficult to quantify, is cognitive overhead. So the analogy I want to use is if you can imagine juggling. It's difficult but doable to stand and juggle something in place. But it's significantly more difficult to juggle something and also walk a tightrope between two buildings at the same time. But sometimes that's kind of what we're asking our teams to do because they're working in a really complicated domain and they're trying to solve some other issue. So they're keeping track of all this complexity in the background and also trying to solve a different problem. And if you can deal with some technical debt, that'll simplify that initial area and give your developers the chance to only worry about juggling, then that'll free up a lot of mental energy for them to focus on the big problems. So those are 3 examples of impact that you can think about. And I think it's worth saying that those will have downstream effects like faster release cycles, happier teams, and simpler onboarding processes in the future. The next dimension that I want you to think about is spread. And we have a little viral emoji up here. I understand if this brings up some bad memories from the last couple of years, but hopefully because of the last couple of years, all of you are familiar with how viruses spread and how quickly that can happen. And related to technical debt, the question here is, how fast is this problem getting worse? So sometimes you have something that's very well isolated. You can go in and fix it, and that's it. But I would say maybe more of the time with these technical debt projects, you have something that is getting worse over time. And this kind of makes sense. Let's say that you want to change the way that you write React components. The longer you put off doing that, every single day you'll have new developers starting, writing new components, and the problem is getting worse as more and more code gets added. So this can also be a good reason to prioritize technical debt. And if you don't have the time to fix the root cause, it might also be worth thinking about trying to stop the bleeding in the meantime. So you can add things like ESLint rules or pre-commit checks, or maybe if you have like a release checklist, a new step in that list, to try and prevent the problem from getting worse until you do the root cause solution, complete the migration, whatever. And the final thing that I want you to think about when you're prioritizing technical debt is the scope, or the surface area of the problem. And the way that I want to frame this is, what is the balloon potential of this issue? So there's the baseline question, which is, have you measured the surface area? Do you know, OK, I have 100 components to update, 10 APIs, 300-something files, whatever it is that you're trying to change. That's your first step. But then you need to go a level deeper and think about whether there are potential complicating factors that could cause this to increase in scope. So a couple of years ago, I worked on a project where we were updating our data access patterns. And it was actually pretty simple and straightforward to make the changes themselves. But when we worked in an area of our code base that had little to no test coverage, very often something would break, and then we would roll something out, have to roll it back, try to figure out what went wrong, potentially add tests, and that added a lot of scope. So several times, something that we estimated would take 1 day ended up taking more like 2 weeks. And you can see how that'll cause a project like this to grow out of control. So the bottom line here is, do you know how long it will take? And really, what is your confidence level about that assessment? If you're 50% confident, that's OK, but it's worth saying that so that you can plan. So at the end of the day, when you're thinking about paying your technical debt, I want you to think about the impact of what you're doing, how fast it's getting worse, and the surface area and your confidence level about that surface area. And you can even rank order these like in a spreadsheet and say, look at, OK, this one impacts this number of customers. It's getting worse very quickly. This is how long we think it'll take, and this is how confident I am about that assessment. And that makes it much easier to prioritize different technical debt projects against each other. So you can use this framework to prioritize projects, but you can also use it to pitch a project if you're trying to justify it to your leadership. If it's not maybe the most high impact thing you're doing, if you can frame it as, OK, yeah, it's not the highest impact, but it's going to be twice as hard in 2 months, that can be a good reason to bring something up on the roadmap. And then finally, when you've prioritized the project and you've gotten it on the roadmap and then you've completed it, at the end of the day, when you go back and celebrate whatever you did, it's good to return to this original rationale. Because if you have a long migration or some kind of project that lasts a number of months, it can be hard to remember the original motivation. So it's important to go back to these reasons when you talk about why you did it, and also throughout the project for the sake of morale. And that's all the time we have. Please join us for questions and office hours, but you can also reach out on Twitter. I enjoy talking about this subject in general. And my name's Amanda Sopkin. Enjoy the rest of your conference.